And with that, it's time to get on to our tech talk for the day. We've got Andrey joining us from Super Protocol, and I will let the team at Super Protocol introduce themselves.
Hello, everyone. While Andrey is sharing our presentation, Andrey, please.
Could you give, thank you. Because
I'm Nukri. I'm founder and CEO of Super Protocol. Here we have Yulia, she's operational director. Andrey, he's our CTO, and Alex, our chief product. Don't hesitate if you have any questions. Please feel free to ask. First of all, a few words about just a few seconds about a brief introduction why we are developing Super Protocol. Our team experience includes we are early adopters of confidential computing, starting from TPM, Intel first version of SGX. With confidential computing spans projects involving large brands, collaboration. First of all, we are oriented to serve collaborations between companies, first of all, like Disney, Pearson, 20th Century Fox, and other media publishers, intellectual property owners, and digital marketing, where companies need to collaborate with each other, but at the same time to prevent leakages, risks of, and cannibalization of business, and so on, so on. In all our projects, we have seen significant growth in the number of collaborations between companies for mutual benefits. The new AI hype have further fueled interest in partnerships and cooperation between many companies. Imagine what we see today. We are analyzing requests coming in Super Protocol. Imagine multiple AI agents, applications, and the data interaction companies who are driving the network economy, ecosystems, collaborations. How do we make that happen? Who verifies that the confidential computing code is correct? Do we trust someone? I mean, global cloud. Who decides who gets connected to the network and who doesn't? Who sets the rules, restrictions, pricing for this collaboration, interactions, and so on? This is exactly why we have created Super Protocol for non-deterministic collaborations. When any project, any partnership, any collaboration is realistic and could be developed for common digital purposes, common business purposes. This is why we developed Super. And Andrey, please go ahead.
Hello, everyone. I'm Andrey Pogoreltsev, CTO at Super Protocol. A few words about myself. I'm a student leader with over 20 years of experience in cryptography, high-level applications, confidential computing, and architecture design. I worked on various projects as a developer, leader, architect, and CTO, specializing on secure and decentralized solutions. Currently, I live in Israel. Today, I'd like to cover 3 main points. First, I'll give you an overview of Super Protocol. This will give you a general understanding of what is it and how it works. Next, I'll dive into a specific scenario involving running AI agents. And finally, I'll highlight the key features of our protocol. These are the crucial aspects that set up apart and make our solution unique. And please feel free to ask questions at any point during the presentation. So, in technical sense, Super Protocol is a confidential and self-sovereign platform that consists of 2 main layers: blockchain, marketplace, and processing. On the blockchain level, we use Polygon blockchain and deploy smart contracts to automate and orchestrate the execution of orders, of offers, and so on within our marketplace. At the execution level, we employ a distributed architecture supported by a network of independent hardware providers from various locations, including clouds and location centers. This combination of our software and independent hardware creates a decentralized and confidential environment. This environment includes our key components such as trusted loader that ensures integrity control and secure transfer of secrets. I will talk more about these components and their functionalities later today. Now, regarding confidential computing setup, each confidential virtual machine is deployed using Intel TDX or AMD CV and NVIDIA H100 in confidential mode. This is a Kubernetes inside the virtual machine to manage all workloads. So now let's look at the scenario for running AI agents. In this scenario, we launch multiple agents within Super Protocol. These AI agents can interact with each other and also generate any additional processing of the results, all within a decentralized confidential environment. To launch an agent, you need to select an engine, provide an AI model, and you can also use dataset for data processing. It's also important that each of these components have different owners, including hardware owners. When we are running multiple AI agents in Super Protocol, we need to focus on several key aspects to ensure security and confidentiality. First of all, we make sure users can review and audit the code of the applications they are launching. This transparency is crucial for building trust. We also have strict controls in place to prevent unauthorized access to the solution and memory during execution. This is vital for maintaining confidentiality, especially when agents are interacting with each other. Another crucial point is to ensure the immutability of the launched applications and data. We ensure that no one can tamper with the agents or information they are processing. We provide trusted reports on the launch of each agent, and the agents themselves can generate reports. This gives users insight into what's happening and helps with accountability. Lastly, we offer tested access to the launch solution. This means users can be confident that they are interacting with genuine unaltered version of the agent they intended to use. All of these measures work together to create a secure, confidential environment. This allows multiple AI agents to interact, process data, and generate results, all without compromising security or trust. It's particularly important in these scenarios when you're selecting engine, providing model, and potentially using data sets for processing. Our safeguards ensure that the entire process from launch to result generation maintains its integrity and confidentiality. All right, let's move on and discuss the key problem the Super Protocol addresses, building on what I've already covered. So one of the main challenges in confidential computing is establishing trust in the execution environment. Super Protocol addresses this directly with its engine web UI. This component serves as a trust anchor for the entire execution system. But what makes the trustworthy, you might ask? Well, the engine is completely open source. This means anyone, developers, users, or third-party auditors, can review the code and verify the integrity. We provide this transparency by making the web UI engine hash publicly available and recorded on the blockchain, so anyone can verify it themselves. And you know, we don't just rely on individual scrutiny. The engine web UI also undergoes thorough security audits conducted by independent organizations. These audits, combined with our ongoing internal reviews, provide multiple layers of verification. Now, once we've established trust in engine web UI, we need to ensure that this trust extends throughout to the execution process. That's where our trusted loader comes in. It's a key component of our protocol that ensures that the code and data are immutable from the moment it's transmitted until the moment it's executed in our confidential virtual machine. And just like the engine WebUI, the entire protocol will be completely open source and subject to continuous audits. This end-to-end transparency and verification process creates a robust foundation of trust for running AI agents and processing sensitive data in our decentralized confidential cloud environment. Building on our discussion of trust and transparency, let's go into how Super Protocol leverages trusted execution environments, OTs, to further enhance security and confidentiality. Yeah. At the heart of our secure computing model is T, a secure area within the processor itself, where code and data can be processed in complete isolation. This isolation ensures that even if the rest of the system is compromised, the operations within the T remain confidential and tamper-proof. But how do you know that your code is actually running inside this secure environment? That's where remote attestation comes in. It's like getting cryptography sign proof that your application has indeed launched inside the T. This mechanism allows users to verify from everywhere in the world that their sensitive computations are being executed in the promised secure environment. Now here, where Super Protocol really stands out, we are not tied to any single T technology. Our platform is T agnostic, meaning we can work with various trusted execution environments. This flexibility is crucial because it allows users to choose the T that best fits their needs. This also means that you are not locked into a single vendor or technology. You can select the T that aligns with your specific security, performance, and hardware requirements. It's all about empowering you to customize your confidential computing setup while maintaining the highest level of security and trust. Okay, great. Let's walk through the crucial process that ensures secure and verified execution in Super Protocol. First up, we have the trusted loader. Think of this as a security gatekeeper. When it starts, it doesn't immediately begin processing orders. Instead, it generates a certificate like a unique cryptographic ID badge. Along with this, it creates that we call a T confirmation block. Yeah, you can see it here. Or TCB. This TCB is essentially a signed report from our remote attestation mechanism, verifying the secure status of the environment. Now, let's say you are the owner of some sensitive data or confidential solution or applications. Before you hand over your valuable assets, you want to be sure that they are going to the safe place, right? So you take this TCB and attestation report and verify it. It's like verifying the security vault before you store your valuables. Once you satisfied that everything checks out, you provide your data solution along with the encryption key to the order. Here where trusted loader steps in again. It analyzes order components to make sure everything is okay. No tampering, no unauthorized changes. Once it happens, it uses the encryption key you provided to decrypt the data or solution, all within the confidential environment we have established. Only after everything is verified, decrypted, and secured, trusted loader passes the order to the Kubernetes for execution. This means your sensitive computations or data processing happen in a completely protected space, invisible from the outside world. This multi-step process ensures that at every stage, from initial setup to final execution, we maintain a chain of trust and verification. It's our way of providing you with the confidence that your confidential computing needs are being met with the utmost security and care. Now, let's break down this next part of the process, which focuses on how we control access to solution and memory during execution. This step is crucial for maintaining trust and transparency throughout the execution of an order. As I told before, the trusted loader springs into action. It creates its own self-signed certificate. Then it publishes the certificate to the blockchain along with the T confirmation block. By putting this information on the blockchain, we are creating a public, immutable record that anyone can verify. Now, when it's time to execute an order, the loader takes an extra step to ensure accountability. It issues a certificate specially for that order. This certificate includes cryptographic hashes of crucial elements like solution being run and data being processed. It's like creating a unique fingerprint for each order. We don't keep this order certificate secret either. The public part of it gets published right in order itself to the blockchain. This means there is a transparent, verifiable record of what's being executed. But we are not done yet. Once all this groundwork is laid, the application running inside a secure environment can generate its own reports. These reports aren't just standalone documents. They are based on the certificate chain that starts with loader, and loader certificate is included in the TE report with remote attestation. This whole process creates a continuous chain of trust and verification. From the moment the loader starts up, through the execution of each order to the final report generated by applications, there are clear cryptographically verifiable trail. It allows anyone to audit the process, ensuring that what's happening inside our confidential computing environment is exactly what's supposed to be happening without ever exposing the sensitive details. This level of transparency and verifiability is crucial in building trust in a confidential and self-sovereign cloud like ours. Okay, and the last thing I wanted to present today is how Super Protocol provides secure access to the confidential computing environment of an order. We've implemented a secure system called tunneling. Imagine creating a secret passage for your AI model to travel across the internet. This tunnel ensures that your sensitive information remains secure and hidden from unauthorized access, and it travels between you and our secure environment. Here, how it works in Super Protocol. We have two main components, the tunnel server and tunnel client. The tunnel server is like the public face of our system. It has a public IP address and can be accessed from the internet using HTTPS. You can interact with it through the web browser or via an API if you're integrating it with other services. Behind this public facade, we have the tunnel client. This is where the real work happens. It runs the web server that processes your request, but it's shielded from direct internet access by tunnel server. This system adds an extra layer of protection against potential attacks. Additionally, this system is designed for scalability. For example, you can run multiple tunnel clients and servers, and they will communicate with each other. The most important thing is that both of the tunnel server and client run in a trusted execution environment on their respective machines, and they mutually attest to each other's integrity. When a confidential application starts a tunnel, it essentially creates a secure trusted channel for communication. The application also includes the TLS certificate for the tunnel in its report, which you can view and verify. This means that you can be confident that when you interact with application, you are doing so over a secure trusted channel. This tunneling approach allows us to offer decentralized confidential computing as a web service, making it accessible and secure. It's our way of bringing the power of confidential computing to the simplest tasks while maintaining the highest standards of security and privacy. So I told you about the Super Protocol and what things it allows you to do. We hope you have some further questions. I will be happy to answer them.
Okay, thanks for the talk, Andrey. While other people are kind of pondering their questions, if you go back a slide, you showed workload. and having, I guess, sort of a hash of the workload. In what we were talking about in the previous topic, the very definition of what a workload is something that we think we might want to explore within the TAC. In your case, what defines a workload?
In our case, workload consists two elements. Yeah, you have solution, its application or Docker image, which is encrypted. Yeah, and also we have input data. And our trusted loader component first checks integrity, because, for example, also we have restrictions here for running, because data owners, for example, can restrict number of solutions or applications which can use this data. And trusted loader checks this everything here. And then also trusted loader decrypts data in solution and create Kubernetes container code. Yeah? It creates container inside code and run it. So in our system now, workloads is a Docker image plus input data.
So does it include an entire pod or just an image, a single container image?
No, it's just a single container right now, but we are going to enhance it, yeah, of course. And we are going to use also virtual machine in future. Allow to run virtual machines.
Yeah.
Okay, thank you.
And also there is a very important thing in this diagram here, that we divide access to the encrypted solution and key to the encrypted solution, and only trusted loader can decrypt this key and use this key to decrypt solution or data, yeah, input data, yeah.
I'm curious,
Okay.
you say that you can check the whole environment hash and run the solution. And I recall from an earlier slide that you said that you store reference values for the hashes in a blockchain someplace. And that sounds good. I'm wondering how, and that your code is open source. So this is great. We've got open source code and a published hash of what a correct build looks like. Do you offer the ability for customers to reproduce the builds and generate their own reference value hashes to make sure that the reference value that's provided in your blockchain is one that I can actually see for myself and verify for myself?
Yeah, we're working on it. We're working on creating reproducible builds. Yeah, we have some maybe problems yet, but we're closer to the end of this work. And our GitHub action will create this build of virtual machine, and everybody can check hashes inside, because we are based on rootfs system with hashes of every components, and everybody can check and reproduce this build using our GitHub action and our open source code. So but Super Protocol is a very big system, yeah, and it's not enough only to allow users to check it, open source code. Also, we are going to make lots of audits of our code of some external organizations, yeah,
Understood.
or universities, yeah.
So what I think is interesting about all of this is the kind of confluence of a number of different technologies here and approaches. One is the kind of Web3 thing where you get to compose what's running and it's not centralized. You get to choose what bits are running, and then using the blockchain both for the, but also for the to record what's actually being run, and then using the Kubernetes world, sort of CNCF type world, and then using confidential computing, and I think it's really interesting to see all of these things coming together. And that's the sort of thing I plan to talk about in Japan as well. But I'm really pleased to have Super Protocol joining the city, to show a different way of thinking about all of these things together. So congratulations, and thank you very much indeed, Andrey, for a really interesting conversation. So many different architectural bits and pieces. As you say, it's very complex, right?
Any other questions for Andrey before we move on here?
So, and of course, the slides will all be available as part of the recording. But are you happy to make the slides available as a separate deck, Andrey, or would you just happy to have them prefer to have them in the recording?
We can rephrase that a little bit differently. So typically, presenters will send their slides to Rian after the meeting, and then we include those in the minutes.
We will send.
Yeah, of
Thank
course,
you.
we'll set everything here.
Okay, sorry that wasn't clear. Thank you, Dan, for using
And
my
if you
mangled
need
English.
any explanation, you can ask other questions here. We will answer them. Yeah.
Thank you.
Well, I recall from earlier talks like Diana's, the difficulty of actually reaching reproducible builds. I kind of feel like this is an area that comes up regularly. We rely on hashes to identify software. We do that pretty freely, but we don't necessarily as a community have a good way to have somebody else verify that identity by having reproducible builds. So I feel like this is an open space for a project within the CCC.
Well,
so
we've been talking about finding academic overlaps as well. There may be some interesting academic work that we could tap into or encourage people to do, frankly. A good master's thesis piece of work, maybe.
Yeah, and Fritz might be watching this on recording. I know he wasn't able to join us today, but he's looking at providing that connection with academia. So maybe just a thought to pull out for Fritz there. Nathaniel commenting in chat there that reproducible builds are very, very hard.
I wondered whether he was going to comment that after our time at Profium.
Always seems like an easy thing to do till you go to do it.
Yeah.
Okay, well, thanks again for the talk today. Happy to have Super Protocol in the family of companies here at the CCC. And as you continue to work on that open source code, keep in mind that we can have it in community governance if that works out for you guys.
So to be specific about the words there, what Dan, I think, is saying is that the Confidential Computer Consortium is always happy to welcome projects, open source projects, and have them as part of the community if it makes sense to do so. So please let us know if that would be an interesting conversation.